Welcome back to our lesson on numerical integration. I thought we'd try a couple examples where we actually have an exact definite integral to estimate, but I picked a couple here where you would not have any method of finding this expression's antiderivative in order to try and use the fundamental theorem of calculus and exactly get the value of this integral. I just don't know what the antiderivative of e to the x squared is. It doesn't fit any of the integration methods that we've learned. But this is a continuous function, and I could graph it in the first quadrant, and we would see that there is area there. And so the only way to evaluate this integral is to estimate its value with a numerical integration method, and we're going to try the trapezoid method today. So in the previous video, the example provided a table of values, and I intentionally made that so that the distance between the sample points was different. But if we're going to make our own table, it certainly seems reasonable we would want to make them all these subintervals the same width. And so that's what I'm instructing us to do in this example. We're going to construct the interval from 0 to 2. And so I'm actually going to start making my own little table here. There will be x, and I'll just call the integrand f of x. We're going to start the table at 0. Now I encourage you to think for a minute here. If we're going to go from 0 to 2 on the x number line and divide it equally into 4 parts, what are we going to have to count by if we're going to do it equally? A quick bit of math tells me I'm going to have to divide by half, count by halves. And so I'm going to use decimal form here. 0, 0 0.5, 1, 1.5, and then finally 2. So we're using 4 subintervals, but we have 5 spots, okay, 5 x values. Now you could, on your calculator, just evaluate the function. I'm just going to write the exact value down for now, if I can. So like if x is 0, 0 squared is 0 still, and this is e to the 0, so I just have 1. For all the rest, I'm just going to write them in terms of e. So if it's 0.5, 0.5 squared is 0.25, so this is going to be e to the 0.25. 1 squared is 1, so this is going to be e to the first. 1.5 squared is 2.25, so this is e to the 2.25. And then finally 2 squared is 4, so this is e to the fourth. So my trapezoids all have a width of 0.5. In a minute, I'm going to make use of that fact to simplify how I write my sum before I actually use my calculator to get the value. But let's just go one trapezoid at a time for now. So in the first interval from 0 to 0.5, I'm going to average the two values of the function, 1 and then e to the 0.25. Take the average of those and multiply by the width, 0.5. And I'll just keep going here. So I'm going to keep writing them out. In fact, what I'm going to do is I'm going to pause my video here, write out the next 4 terms, and I encourage you to write them out as well. And then we'll just check how we check our work in a second here together. Okay, so I wrote out the 4 terms in my trapezoid sum. Each time I was averaging the 2 consecutive function values, multiplying by the width between each value. Each one of them was 0.5 this time. So the 0.5 is the change of x, the delta x. And I just noticed here that every one of these terms has a 0.5 because the delta x was the same in all of them. I also noticed I was dividing by 2 every single time. So I'm going to treat both those operations as a common factor. So the change of x, 0.5, and the process of dividing by 2, that happened every time. So I'm going to be factoring out the 0.5 divided by 2, which is the delta x divided by 2. Now I want you to notice what that left us with. That would leave us by removing the 0.5 divided by 2 and putting that all to the front. Okay, so they're not canceling, they're just kind of all being moved to the front as a common factor that I'm going to apply at the end. notice what that left us with, which will make it easier to type all this into my calculator. I've got the number 1, which was f of 0. That only occurs once, but I noticed that e to the 0.25 is occurring in the first two trapezoids. So I'm going to write that as 2e to the 0.25. And then e to the 1 occurs twice, right there and there. So I'm going to have it there twice. And then e to the 2.25 occurs twice. So I'm going to write it as 2 times this. And then the last term is e to the 4th. Okay, so now to me, this expression now is the one I'm going to type into my calculator if I want to get the answer, because it's a little bit easier to enter into the calculator. Okay, so I encourage you to try that on your own now too. And in a minute, I will do the same thing, and let's check our answer in a little bit here. And I just entered this into my calculator. It gave me the value 20.644. And so that is the approximate value of this definite integral. Now, just for fun, I also entered this integral into my graphing calculator to see what it would give me. And the calculator answer using the integration tool, I'm just going to write it in here too. It was 16.453. So again, the answer we got here is an approximation. We could have gotten it closer to 16 if probably by using more subintervals. Well, I hope this helps, and feel free to contact me if you need help with the assignment today on numerical integration, and we'll look forward to hearing from you. Have a great day.